Hello, this is Mr. Wynn, and this video is about proving triangles congruent. So, last video was about being able to write the 6 equations after being given the congruency statement. Without knowing the triangles are congruent first, we cannot use CP/CTC. So there are 5 different scenarios where once met, we can say or guarantee the two triangles are congruent, and then write the 6 equations. So, the first one is SSS. That stands for side, side, side. So S stands for side, A stands for angle. The description is 3 sides in a row, and here's an example. We have 2 pictures of triangles, and they have 3 pairs of congruent sides. I always like marking this as a side mark, side mark, side mark. The fastest way to connect these 3 is this way. Same thing here. No matter how you connect it, you get SSS, right? But if they match, which they do have to match, that's what they are. Side, 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 congruent. Good. This next one is SAS. That stands for side, angle, side. So it has a side, an angle in the middle, which is also called the included angle, then another side. So in this picture, here's the side marks, here's the angle mark. The angle must be in the middle. Here's the side marks, here's the angle mark. These must be in the middle. The fast way connected will be this way. So this is S to A to S, this is S to A to S. I've had some kids in the past try to say, can we go S all the way around to S to A? And that's wrong. All right, make sure you do it correctly, the shortest path. All right, next one is ASA, so angle, side, angle. Angle, side in the middle, meaning included side, then another angle. So here's 2 pictures. This is an angle marking, this is a side marking, this is angle marking. Fast way to connect those, and I'll try using a different color this time, would be like this, A to S to A. A to S to A. These are both ASA, ASA, that's good. They're matching. That is one of the 5 we're allowed. Once I see that, we can use the 6 equations. Once you write the congruency statement, that is. The 4th one is AAS, 2 angles followed by a side. So 2 angles in a row, then a side. So these triangles, here's the angle mark, side mark. The fastest way you can go is A to S, or you can go SA, it doesn't matter. It's reversible. All right, and on the right triangle, on the triangle on the right side, again, I mark the markings. This goes to S to A, which is saying this A to S. They're matching, that's good. The last one is hypotenuse leg. Hopefully you know hypotenuse only exists for right triangles. So in the right triangle, if you have the hypotenuse marked and any leg marked, you're good. All right, and technically this is ASS, but it has to be in the right triangle. ASS you'll see is really bad, angle, side, side. But look, this is an angle mark, a side mark, a side. Look at this ASS, which usually we avoid and say nope. But unless it's the right triangle, this is a right triangle. This is the hypotenuse. This is a leg. All right, right triangle. This is the hypotenuse marked. This is a leg. Since they're both HL, these are congruent. We can then use the 6 equations after writing the congruency statement. So here's the joke page. The 2 ways you cannot prove that triangles are congruent are AAA and ASS or SA, so you see the donkey. But the bad word is bad. If you have 3 equal angles, 3 pairs of equal angles, does that mean the triangles are congruent? Are they the same size, same shape? Well, if I have 60, 60, 60, like an equilateral triangle, does that tell me what the sides are? No, I could say each side is 7. All right, but here's another triangle down here, 60, 60, but each side is 18. These triangles are not congruent. If I overlap them, they do not match perfectly. All right, so triple angle is not a sufficient condition to prove that 2 triangles are exactly the same. All right, we have something called hidden givens, and these are very, very important. All right, these are the only marks you're allowed to add in a picture if not explicitly given. So the first one's called the reflexive side. Reflexive side means the same side. So if you notice, this blue line in this triangle is the exact same, so I can put a mark there. All right, if I split that triangle, it would be here's the left triangle, here's the right triangle. Notice that these 2 sides would have been exactly the same. Whatever this is on the left, same thing on the right. So that's called the reflexive side or same side mark. Then hopefully you know about vertical angles. So they're constantly the same angle. And the last one is parallel lines. That's a combination. Combination because these are touching. This is the reflexive side. I added a side mark. And then remember, when you have parallel lines in a transversal, you have alternate interior angles. So this angle is the same as this angle, and then this angle is the same as this angle. All right, so that's the harder one, but you'll see that used later. But those are the only marks you're allowed to do. So here's the general process. 3 steps. Step 1, mark the hidden givens. They're not, well, they don't count as missing information. That's on you. And basically ask yourself this question. Are the 2 triangles connected? Are they touching? If they are, there's a hidden given. All right, so notice the first one. These 2 triangles are touching in the middle, right here. In the second one, these 2 triangles are touching right here. Third one, these 2 triangles are touching in the middle. Right, so they're touching, there's probably a hidden mark, either vertical angles or same side. Then you label the marks using A's and S's. Then you check if the marks match and do the 5 sufficient conditions. So triple S, SAS, ASA, AAS, HL. So let's try some problems. Are the following two triangles congruent? If so, state the congruence postulate. So 1, are they touching? Answer is yes. I'm going to put the hidden given. All right, 2, I'm going to label the marks for each triangle because that's all I'm going to mark. This has a side mark and an angle mark. So this is S to A, or A to S, whatever. On the right, other triangle on the right side, this is a side mark, this is an angle mark. Because fastly connected is A to S or S to A, doesn't matter. Are they matching? Yes, but is that one of the 5 sufficient conditions? Answer is no. We need 3 letters. So these are not congruent. We cannot assume they're congruent. Even though they look the same, again, pictures don't match. You can't trust the picture, it's not drawn in scale. Again, we need these 5. So I could have stopped after defining SA. Here's the next one. Are these following two triangles congruent? If so, state the congruence postulate. All right, well, first, are they touching? Answer is yes. Is there a hidden given? Yes. The middle side, the reflexive side. For the top triangle, there's 3 S marks. The fast way to connect it, doesn't matter. Is this is triple S. On the bottom, there's also 3 S marks. The fast way to connect it, doesn't matter. It's triple S. Are they the same thing or matching? Answer is yes. These are congruent. Yes, I'll say congruent. I'll say by SSS. Here's the next one. Are the following two triangles congruent? Are they touching? Answer is no. They're not touching, so there is no hidden given to mark. All right, so I can't add any marks. I just label them. This is top is SS, which I connected to this SS. Is that even one of them? Answer is no. So I can say not congruent, NC. Not enough information, really. Here, even though this SS, they're both SS, that's not one of the 5. I need third side. Even though they look the same, we cannot trust the picture. All right. I mean, here's the exaggerated version. If I had a side that was 2 centimeters and 5 centimeters, I could get this line right here, right? But what if I change the angle? What if I did 2 centimeters this way and 5 centimeters this way? All right, I still have 2 equal sides that match. This side matches this side meets this, but the angle is different. We don't know what the angle is. This bottom triangle is way longer. They're not the same. All right, so 2 equal side marks is not enough to say that they're the same triangle, to guarantee the same triangle. All right, are the two following congruent? If so, the congruence postulate, it's the same thing. So are they touching? Yes, vertical angles. For the top, we have a side mark, an angle mark, and a side mark. If I connect that, that's SAS. For the bottom, we have a side mark, angle mark, side mark. Connect it as fast as possible, SAS. They are matching, so yes, they are congruent by SAS. All right, the angle's in the middle because it's included. It's between the 2 sides. All right, here's the next one. Are they congruent? Let's see. Are they touching? Yes. Vertical angles again. That's all I can add. This is an angle. This is a right angle, but still an angle, and this is a side. Fastly connect. This is S to A or AAS, your choice. Here, this is A to S. All right, are those matching? Answer is yes. Is that one of the 5? Answer is yes. So these are yes. They are congruent by AAS. Postulate. All right, so now let's try some of these. So are they congruent, same thing? If so, write the congruency statement and identify the postulate. So here, are they touching? Answer is yes. I can add a hidden given. On top, I have a side, angle, and side. Fastly connect this will be ASS. All right, now that's bad unless it's a right triangle. Is this a right triangle? Answer is no. So I cannot do anything. So if it's not one of the things, we say not congruent. We can't say triangles, triangles. That's impossible, and there is no postulate we're allowed to use. All right, so be careful. You only fit out if it exists. And ASS is bad unless it's a right triangle. If it's for the right triangle, you'll see HL. I'm not even going to bother with the bottom. Same thing. Are they touching? Answer is yes. Same side, reflexive side. For the top triangle, that is angle, side, angle. That's ASA. That's a good one. So I'm going to check the bottom, see if it matches. That's angle, side, angle. They are matching. So these are congruent by ASA. Now I have to write the triangle congruence statement. So for the QST, that's the bottom triangle. If you have more A's, use the angles to help you. If you have more S's, use the sides to help you. But I'm using angle, so QST. Q has 1 angle mark, S has 2 angle marks, T has 0 angle marks for the bottom triangle. So I'm doing 1, 2, 0. For the top, I'm going to do 1, which is S, angle mark, 2, which is Q, then 0 is R. So I had to do it in that correct order. Once we have the statement, we then write the 6 equations, whatever we need, from CP, Here's the next one. Are they congruent? There's no hidden given because they're not touching. So I label this is a side, this is an angle, this is a side. This is SAS. All right, on this other triangle, look, they have one pair of congruent sides, one pair of congruent angles, 2 pairs of congruent sides. Is that enough? Depends where they are. This is A, this is SS. The way I connect this is AS. This is different. All right, since they're not matching, these are not congruent. You can't say the triangles are the same by whatever. All right, so they must match. So just so y'all know, this one was an included angle, angles in the middle. This one was a non-included angle because it wasn't between the 2 sides. All right, then we have something called additional information given. So here, just type in triangle, that's okay. It says make them the same by ASA. So same idea. There we have an angle mark right here. You see that? They have 2 A's. Now, when is there a hidden given? The answer is yes, they're touching vertical angles. So that's another A. So that doesn't count. That's missing. So we have 2 A's, but we need an ASA. So where does the S go? S has to go between the 2 A's. This is the included side. So I must put it right here and right here. That's the missing S to make it ASA. So the missing mark would have been R to Y because they're saying these are congruent. So what's the missing mark for ASA? It's congruent to I to Y. That's all they want. But once you have that, then you can write the congruency statement. Let's practice that as well. Triangle. On the left one is called RTY. All right, I had to match the angle. See, I have more A's, so I use angles. R has the little angle mark. T has no angle marks, and Y has the double marks. I should have put 2 there. So it's 1, 0, 2. So for the right triangle, I'll go 1, 0, 2. So I has 1 mark, 0 is U, and 2 is Y. There you go. By ASA. All right, here's the next one. What additional information is needed to prove that they're congruent by SAS? They're not touching, so no hidden given. So we already have an S here and S here, but we want SAS. Where's the A? The A is between the 2 S's, so we need this mark right here. We don't know it's 90 degrees, so just don't put 90 degrees. That's the missing A to make it SAS. So we need angle R is congruent or equal to angle M. And let's practice writing the congruence statement. Triangle, let's call that one FRW, why not? All right, we have more S's, we use sides. See, F to R is 1 side mark, then R to W is 2 side marks. So we're going 1 to 2 to 0. So I'm going to go 1 to 2 to 0. So that's the side marks. All right, if you went the other way, you get it wrong. So I have to start at B in this case, then M, then Q, again by SAS. All right, here's the next one. It's a proof. Remember, once you know the triangle is congruent, then we use CP to write any of the 6 equations. It says given L is the midpoint of JM, JK is parallel to NM, prove that JK equals NM. All right, so first are the 2 givens. L is the midpoint and the 2 lines are parallel. Now I'll say, well, what does midpoint mean? If L is the middle of J to M, then this side is equal to this side. So I'll say J to L is equal to L to M. That is definition of midpoint. All right, what else can I do? Well, look, there's a hidden given. I can say these angles are equal. So we can say angle, what is that? KLJ is congruent or equal to angle MLN. That is the vertical angles are equal. Vertical angles are congruent. I'd say vertical angles are congruent or equal. All right, what else is there? Oh, look, the lines are parallel. They're parallel. We can do alternate interior angles. I'll say, oh, this is equal to this. So I'll say angle, I can use K. It's equal to angle N because only 1 letter. That is alternate interior angles. Now look what I have for this. I'll use red. We have AAS. We have AAS. Those connect. So that is, these terms are by AAS. That's the triangle congruent statement. So I'll say triangle AAS. I'll say K, 2 marks, L, 1 mark, J, different marks, equals triangle. 2 marks, 1 mark, different marks. Lastly, once they are congruent, I can do the CPTC. So I'll say they want JK, the third and first, equals NM first and third, that is CP, CTC. And that's it.